Welcome to the 10th and final video to cap off this Java Basics series. We're going to end the series by learning how to build resilient projects that don't crash when an error happens inside of the code. So just to show off why it's important to handle errors and exceptions in our Java code, if we were to run this sample code, which just asks the user for their favorite number, then it asks us what's your favorite number. So we can say something like 7, and it'll tell us that 7's also the computer's favorite as well. However, if we were to run the Java code again, but this time type in something that isn't a number, like say the word apple, then it'll give us an input mismatch exception and completely crash, which isn't really the best user experience. So, as an example, if a common app that you use, like Google Chrome, crashed whenever you typed in a specific phrase, then it wouldn't really be the best for the users who are using that specific browser. So it's important to recognize these errors and handle them effectively so that the user can continue to use the app. So for this example program, we can fix this error of the input being mismatched by using a try-catch block. This is a block of code that in Java basically serves as a safety net to prevent errors from completely crashing the program. So it's very similar to if else, but it works slightly differently. So the syntax is, instead of if and then the condition, there's just the keyword try, and inside the try block is the code that could potentially produce an error. So in our case, that potentially erroneous code would be that code that actually gets the input from the user for their favorite number. And then after the try block, we have a catch block. And so it consists of catch, and then inside a pair of parentheses, the name of a potential error that could occur, and then we can just call that E so that we can easily refer to the error inside of our code that should run if an error occurs inside the catch block. So now we can actually try this out inside of our code. So we can create a try catch block like this with try underscore catch in the autocomplete here. And so it seems like this code here, where it's asking us what's our favorite number, is the code that's actually causing the error. So that's what we'll put inside of our try block. And so it seems like the error that occurs when the input's invalid is an input mismatch exception. So for the exception that could potentially happen here, the data type of E, we can put input mismatch exception. It's part of java.util right here. So now we can press tab or enter, and then it'll automatically import it for us and put it inside the parentheses here. And so inside the catch block, we can just notify the user that their input was invalid. So we can do a print statement here and say, sorry, you did not provide a valid number. And then to prove that this try catch block here is actually preventing our program from crashing, we can add some code after the try catch block to test it. So we can now print out, for example, this code is still running smoothly, and then finally close the scanner to save resources. That's what we had before. So now if we were to run the Java code, if we were to say our favorite number was 6, then it'll just tell us that 6 is its favorite too, and the code is still running smoothly. But now let's try it with some invalid input. So for example, let's say orange, and it tells us, firstly it detects that there's an input mismatch exception that's occurred, and then it tells us that we didn't provide a valid number, and then the code didn't crash and it's still continuing to run, as proven by this code is still running smoothly message that's printed at the end here. So now we know that this code here successfully detects invalid input and notifies the user about it. But there are still other errors that could crop up now inside of this try block here. So now in between clips, you might have noticed that I changed this code to, instead of repeating the number that the user gave and saying it's the computer's favorite number too, I chose to print out 10 divided by the number the user gives. So now if we run the Java code, let's first test it with some invalid input. So we can type the name of another fruit here, plum, and then it detects the invalid input. We can run it with the number 5, and it tells us that 10 divided by 5 is equal to 2. But what if we type in the number 0? So now you can see there's a new error that pops up, an arithmetic exception, because we're dividing 10 by 0. And so the way we can fix this is by adding another catch block. So we can add catch to the end of this first catch block to create another one. This time to detect arithmetic exceptions. And then we can also call the arithmetic exception E as well. And so for this, the cause of an arithmetic exception is different from an input mismatch exception. Instead of providing invalid input, we have to divide by 0 for this to happen. So we can tell the user, sorry, this program tried to divide by 0. And so now if we were to run this code and type in 0, you can see that this program not only detects invalid input, but also detects invalid division by 0, which helps prevent any possible errors. But sometimes, even if we thought we'd fixed all the errors, there's still some errors that get left under the cracks. So in order to catch any other possible error that could arise, we can create yet another catch block. But this time, the exception type is just the generic exception here. And this exception can also be called E. And so basically, in summary, all the other exception types, like arithmetic exception and input mismatch exception, they're all child classes of exception. It's similar to what we learned in the previous video where we learned about inheritance. Arithmetic exception and input mismatch exception all inherit from the same generic exception class, meaning we can detect all exceptions after we've detected for specific ones in case any other error occurs other than these two exceptions. So now we can print out, sorry, something else went wrong, because neither invalid input occurred nor division by 0 occurred, so something else has to have gone wrong. And also the order of these catch blocks with these specific exceptions also matters. So, for example, if we were to put this generic exception catch block at the top, then you can see there's some errors that show up inside of our VS Code window. It's saying unreachable catch block for input mismatch exception, and the arithmetic exception is also unreachable. It's saying it's already handled by the catch block for exception. So, as I explained before, all of these different types of exceptions, like input mismatch exception and arithmetic exception, they're all child classes of exception. Meaning that if you put exception at the top here, then it'll catch all errors and then just print out something else went wrong. And then, because no other errors happened, it won't even look at these later catch blocks because all errors are automatically handled by this generic exception catch block. So, for writing try catch blocks, the best strategy is to put in the most specific exceptions up at the top here, and then leave the generic exception class for the very end. So that way, you can narrow down the problem as much as possible, and only if something else truly went wrong and it doesn't match anything else that could have caused any other known error, only then it tells you that something else went wrong. So now we're ready to learn about the final concept of today's video, the finally block. This is an optional part of the try catch block from earlier, which will run no matter what has happened, whether a crash has occurred, an error or exception has occurred, or if it didn't occur. So it's typically used for cleaning up, involving actions like closing a database connection or closing a scanner object to save our computer's resources. So in our project, what we can do is add a finally block here. And then what we want to do is, because we're done using the scanner now, we can close the scanner with the input.close here. And we can move it to the finally block to ensure that everything is cleaned up after we've actually processed the favorite number or processed any of the exceptions that we handle in these catch blocks. So now we're fully done learning new things in the Java Basics series. So let's finish it off with a final challenge. So for this final challenge, what you want to do is create an array of names of people who know or people who you're close to. And so what you want to do is ask the user to provide a number that serves as an index to access a name that's then printed out to them in the terminal. So this is known to be a really erroneous operation in programming. So what you want to do is test your project with various inputs, and then after that testing, use all the exceptions that you've found to prevent all possible errors that could be caused from this program. And make sure to print out nice friendly messages if errors actually occur to the user. Thank you very much for tuning into the whole series. Like and subscribe if you enjoyed it. And be on the lookout for the next series coming up, where we'll learn how to streamline our Java coding experience through the power of AI. See you all soon.